Here's the question then, part A and part B. Okay, so let's have a look at it here. I've got it summarized here. Given that theta is equal to 20, show that theta is equal to this. So let's separate the variables and integrate then in part A. So here, let's move the 120 minus theta down. 1 over 120 minus theta. Leave the d theta as is. Leave the lambda as is and move the dt up to be with it. Separate the variables and integrating. Gives, well, this one is log of the 120 minus theta. Log of something goes to 1 over something multiplied by the something differentiated, so a minus will come out. We don't want a minus, so let's put 1 there to counteract the minus to make it a plus 1 not of. Is equal to the lambda t then, t plus k. So that tells us then move the minus over, ln 120 minus theta is equal to minus lambda t minus k. Okay, so unwrap the log. So 120 minus theta. The e log base e comes up and hits this in the air. E to the minus lambda t minus k. So that tells us that theta is equal to, then move this over there, leave the 120 as is, and move this stuff here across to be a minus with it. And that's equal to, theta is equal to 120 minus, now this properties of exponentials, it will be e to the minus k times e to the minus lambda t. If we let, what value of the thing have we got? Let k equal minus, let k equal e to the minus little k, then we can see that theta will have the form of 120 minus k e to the minus lambda t. So there's what we've got then. Now theta equals 20 when t is 0. Let's see what the value of k is. Theta equals 20, t equals 0, gives 20 is 120 minus k e to the 0, minus 0 is e to 0 is 1, so that tells us what k is. Move the k over there, and then move the 20 over there. So k times 1 is k, move that over there, move the 20 over that, k is 100. So theta is equal to 120 minus 100 e to the minus lambda t, which is what we wanted to show here. When theta equals 100, the kettle is switched off. Given lambda equals 0.01, find the time to the nearest second when the kettle is switched off. Theta is equal to 100 then, and lambda is equal to 0.01, gives, so 100 equals 120 minus 100 e to the minus 0.01 t. Move this over there. So I've moved that across the equals. Move the 100 to minus 100. 120 minus 100 is just 20. Now we can just take that over. So e to the minus 0.01 t is equal to 2 over 10 is 0.2, isn't it? Now write this in log form. 0.01 t is equal to, the e comes down to be the base number, so it's natural logarithm of 0.2. This is 100th. So times by minus 100 both sides, and we get t minus 100 ln 0.2, which equals, so we need to work that out to the nearest second. So here we go then, let's have a look at this then. Minus 100 times natural logarithm of 0.2 equals 160.9, which is 161 seconds. That's to the nearest second, which is what we wanted to show, didn't we? Find the time to the nearest second when the kettle is switched off. It's after 161 seconds.